Okay, so in this video, I'm going to go through some example problems from modules 3, 4, and 5, okay, as you prepare for the exam. So you should, at this point, have printed the exam list of topics and be checking off as you feel comfortable with each topic. Additionally, you should print off the formula sheet that will be provided for you during the exam. Notice these formulas here. These are from Module 3, and so you might be using these, and just you want to be familiar with which formulas you'll be given and which you won't. Some formulas you will need to memorize, but the mean for data, mean for a frequency table, standard deviation, and the shortcut standard deviation, and the variance equation are all going to be provided. So get used to using these. Okay? Alright, so Module 3, it's all about finding measures of center, finding measures of variation, and then interpreting those measures of center and variation and finding what values are considered to be extreme, okay, or unusual values due to the range rule of thumb. So starting with finding a mean, here we have seven friends, asked how many cousins they had. So first friend had 16 cousins, second friend had 11 cousins, etc. So find the mean number of cousins. So x bar, this is the sum of the data divided by the sample size n. So the sum of the data, you'd go ahead and pull out your calculator and sum up 16 plus 11 plus 4 plus 9 plus 5, 2, and 8, and you get 55. Total number of data, we have 7 data points, so divide that by 7, and you get 7.857. Now here I don't clearly specify how many decimal points I want, but on the exam I will. So pay attention to what the exam says. Here, I'll go ahead and round this to 2 decimal places. A lot of times for means, we round it to 2 decimal places, but it depends on the data and how many decimal points the original data has. So if I round this to 2, this would be 8, 6, right? That 7 will round that 5 up to a 6. All right. The median number of cousins. So first thing you want to do when you're finding the median is order the data. So 2, 4, 5, 8, 9, 11, 16. After you've ordered it, double check 1, 2, 3, 4, 5, 6, 7. Still have 7 data points. All right. Sometimes when you have a small data set like this, you can find the median kind of by looking, or you can cross out each side and count inwards, right? Or you could use the 50th percentile rule that was, I think percentiles were discussed in Module 4, but now that you know it, you can find the median using that equation. L equals K over 100 times N, where K is whatever percentile you're doing, so 50 divided by 100 times 7. Okay, so basically 0.5 times 7 is 3.5. Remember, this L was the rank of the whatever percentile you're looking for, and it's always an underestimate, so you always round upwards. So 3.5 would go to the 4th observation, so that's 1, 2, 3, 4. 4th observation is 8. Okay, so what's the median? 8 is the median. Okay, find the mid-range. Okay. So the mid-range is the middle of the range, right? So it's basically a midpoint, right? All midpoint calculations are basically the average of endpoints. So what we will do is we'll average up the 2 and the 16. 2 plus 16 and divide that by 2, and we get 18 divided by 2, which is 9. All right. Find the mode. Mode is the number that occurs the most often. And let's see, are any of these numbers ever repeated? No. So since no number is ever repeated, there is no mode for this data. Okay. Find the variance. Now, variance, remember, is it's the standard deviation equation without the square root, right? If you square the variance, if you square the standard deviation, you get the variance. So I can use either equation here. I'll go ahead and use this equation, but the shortcut formula is better, so if you're comfortable with that, I would go ahead and use that one. It's always faster and better. Less rounding errors when you're using that one. Okay? Alright, so I'll go ahead and use the long formula, though, for right now. So the variance, S squared, right, equals the sum of x minus x bar squared divided by n minus 1. Okay. So a lot of times when I'm calculating this, I like to make a table. So first I start with x, my data, 16, 11, 4, 9, 5, 2, and 8. Okay, that's the first column. Next I have x minus x bar, and then after that I have x minus x bar squared. Okay? Alright, once I sum up this column here, that will be the sum of x minus x bar squared, which is the numerator, which is what you see there. Okay, so that's the idea behind putting this table together. So x bar is 7.86. So what I'll go ahead and do is I would say 16 minus 7.86. Okay, and I get 8.14, and then I would go ahead and square that guy, 66.2596. Okay, then I'd say 11 minus 7.86, and I get 3.14. Go ahead and square that guy, 9.8596. All right, I'm going to go ahead and fill out the rest of this table. I'll fast forward the video so that way you don't have to watch me filling it out. But you can check that my table matches your table. Okay, so now if I sum up this entire last column here, I get 134.8572. Okay, I want to be careful that when I square negative numbers, I get a positive number. Okay, so don't forget that a square of a negative is a positive. All right, so when I'm summing up these numbers here, they're all positive numbers, and I get 134.8572. All right, so let me go ahead and write that here. 8572 divided by n minus 1. Okay, so 7 minus 1, which is 6. So when I take this and divide it by 6, I get 22.4762. Okay, if I were to round that maybe to 2 decimal places, 22.48, right? That's 6, rounds at 7 to an 8. All right. Moving on to the next question. Find the standard deviation for the number of cousins. Now remember, standard deviation is just the square root of the variance. So take the variance and take the square root of it. Now, when you're taking the square root, don't use the rounded number, okay? Use all the decimals that you have and take the square root of that number, okay? So I'm going to go and do that here. I'll say second square root of second answer, 4.74. 4.74. If I was rounding to 2 decimal places, I would go ahead and leave it there. Okay. Find the range. So the range is the max minus the min. Okay, so what's my biggest number? 16, and my smallest number is 2. So 16 minus 2 is 14. All right, are there any unusual values? So use the range rule of thumb. So the range rule of thumb, we would, sometimes drawing this out is helpful. Okay, so our middle, where the mean is, okay, so the mean is at 7.86. Okay, and we would go 2 standard deviations below the mean and 2 standard deviations above the mean. Okay, and then anything between that would be considered usual. All right, so 2 standard deviations below the mean, I would take 7.86 and I would minus 2 times 4.74, right? The standard deviation. So 7.86 minus 2 times 4.74, and that brings me to negative 1.62. Okay, and then do the same thing up here, 7.86, and then add on 2 times 4.74. Okay, so same thing, let's just change that minus sign to a plus sign, and I get 17.34. Okay, do I have any observations that are outside that? Right, this in this range is the usual values. So anything in here is considered usual. Anything outside is considered unusual. Well, all of my data is between 2 and 16, so all of my data is in the usual area. So there are no unusual values. All right. Okay. Moving on to the next question. Customer service department of a phone company is experimenting with 2 different systems. On Monday, they try the first system, which is an automated menu system. Gosh, I hate those automated menu systems, right? And then on Tuesday, they try the second, which is the live agent. Always much better when you get a live agent, right? The quality control manager selects a sample of 7 calls each day. He records the time each customer for each customer to have his question answered. Okay, so maybe even though we all hated the automated agent, maybe it's actually faster. So in which case, that's a good thing, I guess. So we want to determine the coefficient of variation for both data sets, and then we basically want to compare the variation. Okay. So first thing you're going to want to do when you're finding a coefficient of variation is remember what the formula is for coefficient of variation. It's not on your formula sheet, so this is one that you do need to memorize, right? So coefficient of variation, it's basically a standardized measure of variation. So what do you standardize it by? The mean. So, oops, let me write that differently. S divided by X bar times 100%. We always report coefficient of standard deviation as a percentage. So S, the standard deviation, divided by X bar times 100%. So it's standard deviation standardized by the sample mean. All right. So now we need to figure out what is for the automated. I'll use automated is 1, live is 2. Okay. So what is S1? What is the standard deviation for the automated menu? So you would have to go through the same steps that I did when I was calculating the standard deviation for the number of cousins. All right, I'm going to save us time and tell you what it is, but please double check that you are able to do this on your own. And if you don't get the same answer as me, post the discussion board and we can talk about it. Okay, so what do I get? I get 2.90 for my standard deviation. Okay, and what do I get for my mean? For the mean for the live agents, X bar, 6.60. Okay, now, sorry, these are for the automated menu, right? So for the automated menu, 2.90 and 6.60. So for the live agent, S2, standard deviation for the live agent is 1.28. And the mean for the live agent is 4.26. Okay, so when you're looking at this raw data that we have here, it looks like the automated menu does take longer, and there's more variability around it, right? So maybe some of these guys are actually finishing shorter than the amount of time than these guys because that variability is so big. Okay, the variability here is much smaller for the live agent. All right, so now let's go ahead and do a coefficient of variation for each of these. So 2.90 divided by 6.60 times 100%. We get 43.95%. Okay. The coefficient of variation here would be 1.28 divided by 4.26 times 100%. And we get 30.17%. Okay. So relative to the mean, which one has more variation? Right? The variation for the live agent is less. So if we were to compare these guys, we would say the variation for the live agent is less, right? 30.17 compared to 43.95. All right, so that's calculating means and standard deviations and coefficient of variations. Okay, so we actually have one more mean, two different types of means that we want to talk about. Means for a frequency table and weighted means. Okay, that finishes up Module 3, so we'll talk about these two things. So here we have the highway speeds of cars are summarized using this frequency distribution, and we want to find the mean speed. Okay, so frequency distribution mean, it is on your table, so you could write down that equation if that helps you. X bar equals sum of f times x divided by the sum of f. All right, so let's see. What is x though, right? We have a range for the speed, not just one particular x value, right? So what do? We find the middle of that range, right? So we find the midpoint for each of these columns in the frequency table. So, or for each of these classes. So this first mid-range is 34.5, right? How did I get that? You do 30 plus 39 and then divide that by 2, right? It's the middle between 30 and 39. 44.5, 54.5, 64.5, 74.5. All right. This number of cars, this is our frequency. This is f. Okay? So what I want to do now is I want to create another table. I'm going to do x, f times x. So 34.5, 44.5, 54.5, 64.5, 74.5. 3... Okay, and now I'm going to go and multiply 3 times 34.5. I'm going to fill out this this column here. 34.5 times 3. I'll go ahead and fast forward the video, fill this out, and you can check, see if you have the same things here. Okay, so the numerator here is 5650. The denominator is the sum of F, right? So I can sum that up here. So 3 okay, and I get 100. So 5650 divided by 100 is 56.5. Right, so that's the average speed for those 100 cars. All right, moving on. We have a GPA problem now. GPA problems are really popular, so make sure you feel comfortable doing this type of problem. So we have a student who earns a grades A or C, A, B, and A. Okay, so let me go and write that down. Her grades C, A, B, and A. Okay. Those courses had corresponding credit hours. So if I write credits of 4, 6, 1, and 6. And these are the points for the grades. So C is worth 2 points, A is worth 4 points, B is worth 3 points, and an A is worth 4 points. Okay, compute the GPA. All right. So just like the frequency mean, it's exactly the same formula except replace F with a W. All right, but it's exactly the same formula, weighted mean. So it's the sum of W times X divided by the sum of W. Okay, so GPA is a weighted mean. Now your grade is weighted by the number of credits that you take. So this is W. This is X, the data, your grades. Right, that's what you calculate GPA based off of your grades. Okay, so I'm going to make a column here that is X or W times X. Okay, so 2 times 4 is 8. 6 times 4 is, 24. 1 times 3 is 3. 6 times 4 is 24. Now I'm going to add up each of these, everyone in that column. So 8 plus 24 plus 3 plus 24. And I get 59. So that's my numerator. Okay, 59. That's the sum. Okay, now I need the sum of W. So I need to sum up this one. So that's 10, 11, 17. Okay, so I take 59 and I divide 17. And I get 3.47. Alright, makes sense. She got 2 A's and 6 credit classes, so those are heavily weighted classes. So yeah, it makes sense that her grade here is her GPA for the semester is 3.47. Alright, moving on to module number 4. I'm going to go ahead and pause the video and I'll restart it with a new video.